Okay, so today is January 19th, 2012. We're on Chapter 7 review. Ninth. Ooh, sorry. Ninth. What we're going to do is I'm going to go through your review. The very first question refers to Lesson 7.2. So the first question refers to our multiplication rule. Our multiplication rule says that if the bases are the same, so we have x to the power of a. Okay, so multiplication rule says that if the bases are the same, the base is x, we can combine this to one exponent and we're going to add the two exponents. Now this is if you're multiplying the numbers by each other. So in this case, we have the number 3 as our base. Okay? So our base will underline in red here. As long as the base is the same, our answer is going to have the same base. So what will be the base of our answer? 3, that's right. Now we need to figure out the exponents. We add them together. The first exponent is a 4. Okay. First exponent's a 4. Second one is an 8. What is the exponent on the third number? Very good, 1. So we took base 3, 4, plus 8, plus 1, 3 to the power of 13. That's all I wanted you guys to do. I don't want you to solve for 3 to the power of 13. I want you to simplify it as a single exponent. So, question 1b. Same idea. This time our numbers are being divided by each other. Okay. So, again, our bases are the same. So we're going to underline the bases here. And our exponents, we can combine our answer into one base, which is the base we already have. So since our base is -5 in this question, we know our answer is going to be the base of -5. And we take our exponents and we're going to subtract them when they're divided by each other. So when it was multiplied, we added them. When it was division, we subtract. So we take 6. You take the top number, subtract the bottom one. And we end up with -5 to the power of 2. So this is a single positive exponent. That's it. That's our division rule. That would be simplifying the second one. Okay, so the next question, 1c. We have a multiplication and division. So in other words, we're going to be using our multiplication rule and our division rule. Now technically this says these two numbers divided by this. So by bedmass order of operation, we're going to deal with the top of the fraction first. Now the same idea as we had before. The bases are the same. So when we combine them, we're just going to have one base. And we're going to add the two exponents because they're multiplication. So we have 4 to the power of 12. 7 plus 5 is 12. Divided by 4 to the power of 12. Okay? Now, with division, what do I do to combine these? I subtract. So I have the same base. I subtract the top from the bottom. I get 4 to the power of 0. Now, this is where another rule comes in handy. If you guys notice, this is the rule with a 0 exponent. Any number, x represents any number, to the power of 0 is equal to 1. Okay? So 4 to the power of 0, you can even type it in your calculator if you like. Any number to the power of 0 is equal to 1. So the answer to this question would just be 1. So the next question, and remember, the question we're working with says we want positive exponents. So again, I have a division question. We know we're going to be using our division rule. The bases are the same. So we keep the same base. We subtract the top number from the bottom. So we have 5, subtract 9, 4, or 11 to the power of -4. Now the question says it wants a single positive exponent. This is a negative exponent, so I have to switch it. That's where I use my negative exponent rule. Okay? If a number is to a negative exponent, to make it positive, I invert the fraction. So technically this is 11 over 1. Okay, so we have an imaginary 1 here, we'll say. I'm going to flip that number. And when I flip this number, I get 1 over 11 to the power of positive 4. Okay, so this is our positive 4. This could also be written 1 over 11 to the power of positive 4. Both will give you the same answer. Okay, and I'm gonna actually show you guys how to multiply this right now as an exponent. I know fractions tend to give people quite a bit of difficulty. So, and the reason this works is I'm going to show you how to multiply this. We all know that an exponent just means whatever the base is times itself that many times. So since the base is 1 over 11 in this question, now remember, we're technically done for what this question asks. I'm extending it so you guys understand. The base is 1 over 11. So I take 1 over 11 and I multiply 1 over 11 by 1 over 11. How many times? 4, because it's to the power of 4. Okay. So when we multiply fractions, we do the top by the top and the bottom by the bottom. When I multiply the top numbers by themselves, what am I going to get? 1. So that's why this works up here. That's why I have a 1 at the top. That's not going to change. The number 1, no matter how many times I multiply it by itself, it stays at 1. So if this question said to evaluate, I would then have to do 11 to the power of 4, 14,641. Now I have not asked you to evaluate in this question. There are questions I'll ask you to evaluate with. You're allowed to use a calculator for this test. But if I ask you to express as a single positive exponent, this was the answer I'm looking for, okay? Make sure you put it like that. Read the question carefully. If it says evaluate, you give me that. If it says a single positive exponent, you give me the other version. Okay, question 1D. This question we have a power of a power, okay? The power of a power is this rule here. We use the same base as before. So our base is -9, so we know that our answer is going to have base -9. But when we have a power of a power for our two exponents, we multiply the two numbers by each other. So in this case, I'm going to be multiplying 2 by 5. So we'll have base 9 as our answer to the power of 10. That's a single positive exponent. Okay, question F. Now remember I told you guys, we are still, because we're evaluating or simplifying, we still have to follow BEDMAS. So in this question I have a division and I have a power of a power, which is essentially exponent of an exponent. So I'm actually going to deal with the exponents first. So I'm going to be using my power of a power rule first, then my division rule second. So we keep the number on top the same, 6 to the power of 10. Our base still stays as 6, but I'm going to multiply these because they're a power of a power. So I do 6 times 2. So we have 6 to the power of 10 divided by 6 to the power of 12. Our division rule means we subtract these two, same base, 10 subtract 12, 6 to the power of -2. That's right, I need to put it positive, so 1 over 6 to the power of 2. Or you can write like 1 over 6 to the power of 2. Either will work. Okay, question 4a. We're going to be doing radical exponents. So this is an exponent that is a fraction, which means it's in a radical form. Okay, this is an exponential form. I want you to put these into radical form, or you guys will know what it looks like a root. Now you guys are used to only square roots, which is a root of 2, but there's actually many other types of roots. They're called radicals. So in this one, our base is 36. Okay, and in this question, our base is x. The numerator, or the number on the top of the fraction, is a and 1. So, in radical form, what I do is I take my base and it becomes the number underneath the root. So 36 is the number in the root. I take the numerator, or the number on top, and I put the number in the root to that power. So 36, in this case, the number is 1. So 36 to the power of 1. And I take the number on the bottom of the fraction, that's the root. So because it's the number 2, that's called a square root. 36 to the power of 1 is just 36. And what is the square root of 36? 6. The root means that some number times itself twice to get what we're looking for. So we do 6 is the square root of 36 because 6 times 6 is equal to 36. So another example of this, which would be our example B. Yeah, this is our radical form here. This one or this one, both are radical form. If it said to evaluate, your answer would be 6. Yeah, you'd be evaluating.
In the last Harry Potter movie, like they actually had characters who were wearing like the Smashers who had like rabbit models were wearing like red armbands.
Yeah, you're right, they were.